Hey guys, wanted to do a quick review for you. This is over how to find oxidation numbers. There'll be another review that talks about how to find what has been oxidized and reduced in an actual equation. But first, we need to go over some of the rules. Rule number one, do you have a free element? Free element again means that it's something that's not chemically combined with anything else. It's all by itself. That's the one most people are going to forget. So don't forget that rule. Free element, all by itself. It has an oxidation number of 0. Rule number 2. Now in your book it talks about, is it a simple monatomic ion? Well, for us, usually the only simple monatomic ions we look at are whether or not it's a metal in a compound or a metal that has a charge. There's some others, I'll show you an example, but that's the main one. So I always put metal question mark. Number 3, what is the sum of the oxidation numbers? The sum of the oxidation numbers equal the charge on the molecule. The sum of the oxidation numbers equal the charge on the molecule. And then there's 3 that they're special. They like to have their own unique oxidation number. Fluorine is normally a -1. Hydrogen is normally a +1. And oxygen is normally a -2. So let's see how we would use these. So here are 3 examples of compounds wanting us to find their oxidation numbers. The first one is a sulfur monoxide, SO. We're going to go through the list of rules. Notice I've put them over to the side. Number 1, is it a free element? No, we have a compound in this case, so that doesn't apply. Do I have a metal? Nope, no metal. The sum, if I add together the oxidation numbers for sulfur and oxygen, it will equal the charge on the molecule. In this case, that charge is 0. And then do I have any special elements? Well, I know oxygen likes to be a -2, so I can solve for sulfur. I'm going to say I have 1 sulfur, it's X, and I have 1 oxygen, which is a -2. And then I'm going to simplify. X minus 2 equals 0. X equals a +2. So sulfur likes to be a +2. Now next, we're going to do another sulfur-containing compound. We're going to do sulfur dioxide. Free element? No. Metal? No. Sum? Again, there's no charge. The charge would be in the upper right-hand corner. There's nothing there. So I know that whenever I add them together, it's going to equal 0. I know oxygen likes to be a -2. I'm going to solve for sulfur. I have 1 sulfur, it's X. I have 2 oxygens, they like to be -2. And when I add them together, it's 0. X minus 4 equals 0. X equals +4. So if you notice in these 2 examples, even though they're both just sulfur and oxygen, the oxidation number of sulfur has changed. That's very, very common. Sulfur likes to have different oxidation numbers. All right, one last one on this slide. Sulfur trioxide. Free element? No. Metal? No. Sum? It's going to equal 0. Let me change colors again. Oxygen still likes to be a -2. Let's solve for sulfur. 1 times X plus 3 times -2 equals 0. X minus 6 equals 0. X equals a +6. Let's try a few more. A few more examples for you. S8. Let's go to our list of rules. Do I have a free element? Did you catch it? This is a free element. So since it's a free element, its oxidation number is 0. That is the one that most people will forget. So don't miss out on those easy points for the test. Next one, SO3 with a -2 charge. This is the sulfite ion. Free element? Nope. Metal? Nope. When I add them together, remember that equals the charge on the molecule. In this case, it's a -2. Do I have any special rules? I know oxygen likes to be -2. So let's see here. I have 1 sulfur, it's X. I have 3 oxygens, they like to be -2. And when I add them all together, it's still going to equal -2. X minus 6 equals -2. X equals +4. The last example on this slide is the sulfate ion. Free element? Nope. Do I have a metal? Nope. The sum's going to equal -2. It's going to equal that charge. And I know my oxygens like to have a -2 oxidation number. 1 sulfur, which is X, 4 oxygens times -2 equals -2. X minus 8 equals -2. X equals +6. Now, you may have remembered in class, we talked about this particular ion. We use sulfate a lot in these examples. And sulfur in sulfate is a +6. But if it was in any other compound, it wouldn't be a +6 anymore. It would change depending on what compound you have it in. So in the previous example, we have sulfite, where it's only a +4. So be careful. All right, one more page, one more slide. This is the last slide of those examples. The first one up on top, this is a hydrogen sulfide. So nope, it's not a free element. I have 2 elements up there. No metal. The sum, well, this one's neutral, so the sum would equal 0. And I know hydrogen likes to be +1. And I'm going to solve for sulfur. I have 2 hydrogens. They like to be +1. I have 1 sulfur, which is X. 2 plus X equals 0. X equals, a -2. Now, on the previous examples, sulfur was always positive, but sulfur likes to change a lot. So does chlorine, so does nitrogen. Many elements, especially your nonmetals, will do this. Next one, this is sulfuric acid, H2SO4. Now on this one, we have a multitude of different elements here. There's 3 in there. So let's go through. Well, free element, no. Metal, no. When I add them together, well, they're going to equal 0. I know hydrogen likes to be a +1. I know oxygen likes to be a -2. There's 2 hydrogens times a +1, 1 sulfur times X, 4 oxygens times a -2. 2 plus X minus 8 equals 0. X minus 6 equals 0. X equals +6. Now I could have skipped some of that. This is actually the sulfate ion. We know that sulfur in sulfate likes to be a +6, but you can always double check yourself just to make sure. The one on the bottom, now this is a sulfide. This is an ion. This is an example of where we would have a simple monatomic ion. Remember that rule number 2, which I said normally we look at it whenever it's a metal. Well, this is not a free element because it's not neutral. It actually has a charge associated with it. So in this case, sulfur would actually have an oxidation number of -2. Now I wanted to do one more example. Oh, let's see here. Which one should I do? Let's do sodium sulfide. There we go. Na2S. Free element? No. Do I have a metal? Yes. Sodium is my metal. So I'm going to look to see what charge it normally has. Sodium is normally a +1. The sum is going to equal 0. And I'm going to solve for sulfur. I have 2 sodiums. They're +1. I have 1 sulfur. It's X. 2 plus X equals 0. X equals a -2. Well, there's your quick review. Enjoy. And if you have any questions, let me know.